Tidak pakain mak.
Yes, my voice is audible.
Yes, sir, audible.
Okay, 1 minute, ma. Yes, PPT is visible. Yes, give me the response. PPT is visible.
Yes, sir.
Yeah, thank you. Yes, yeah. The given mechanism is a slider crank mechanism, right? The given mechanism, slider crank mechanism, the link AO is, it is a fixed link. AB is, link 2 is a crank. It undergoes a complete rotation. That's why the link undergoes complete rotation is nothing. That link in name it as a crank. Now what is the link 3? It is OC. It is a slotted link. It undergoes a oscillation. It will not undergoes complete rotation. It undergoes oscillation. At the same time, in the slotted link, here it is in the slotted portion, the slider is there. There is a link number 4. It will slide inside the slotted link. Means it's reciprocate inside the slotted link. At the same time, what happens? Link number 5 is also moves like this, right? And also at the same time, it also oscillates. Link number 5 is also oscillate. At the same time, also moves linearly. Right? What is the link number 6? The link number 6 undergoes a linear or rectilinear motion or reciprocating motion. That is slider is the, it undergoes a quick return motion, right? And for cutting stroke, the time taken for cutting stroke is more and time taken for return stroke is less. That's why it called the quick return motion mechanism, right? Now first, whenever the problem is given, the sketch of the mechanism given, remember the steps. What is the step? What are the steps are there? 6 steps are there. First one is identify the type of mechanism. Here what type of mechanism here is given? It is a quick return motion
Return mechanism.
Next, second, what is the second step? Draw a space diagram for the mechanism by taking a suitable scale, right? Now here see that in the problem is mu is given. Mu, whenever the mu is comes, whenever mu is given, consider friction in the mechanism. Again, the mu is given for what type of pair here? Mu is given only for sliding pair. We have two sliding pair here. One is at the sliding pair between link 1 and link 6. Another sliding pair is between link 3 and link 4. Right? These two are the sliding pair is there. Whenever the mu is given, now consider the friction in the mechanism. Then how mu value is given? Then I want to calculate a limiting angle of friction. How to calculate limiting angle of friction? As you know that the law of friction force is directly proportional to normal reaction. Then you go for simplify it. Finally, we will get tan pi is equal to mu. From this, mu is equal to 0.15. Then pi is equal to what? Tan inverse of mu. Then substitute. Finally, we will get pi is equal to 8.53 degree. Now remember this value for this problem. Because the limiting angle of friction is how much? 8.53. Okay. Now first step, identify the type of mechanism. Second step, draw the space diagram. Right. Now how do you draw the space diagram here? By taking a suitable scale. What is the scale I have chosen here? Here I have chosen, see all the dimensions are in, see the sketch here, 400 mm, 400 mm, and crank AB is I think 100 mm, right? So on the OC, see the dimension AB is, crank AB is 200 mm, sorry, 200 mm, OC is 800 mm, again CD is 300 mm. The 1:1 scale is not possible. That's why we'll go for a reduced scale. What is the reduced scale here? Now chosen here it is a 10:1 scale. What is 10:1 means? 10 mm on converted into 1 mm or 10 centimeter is equal to 1 centimeter. Right? By taking a suitable scale, then draw the space diagram. The figure A shows what? This is the figure A we called as. Figure A is nothing but space diagram for the given mechanism. How do you draw the space diagram? Now see the draw a vertical line. Along the vertical line, mark a point A, then O. AO is how much? AO is how much here? Yes. Now AO is given here itself in the drawing itself is given, right? How much is given? 400 mm. For 400 mm, connect into 400 mm into how much? 100 mm. Sorry, 100 mm. Sorry, 40 mm. 10:1, right? 400 mm is equal to 40 mm or nothing but 4 centimeter. Draw a vertical line. On the vertical line, measure point A. Then along the vertical line, measure 4 centimeter. Then mark a point that is O. AO you will get. Then in freehand sketch, you draw this bearings. Okay, fixed link you draw it from the point A. What is the angle? Theta is given 105, right? Theta is 105 degree. With respect to AO, I draw a 105 degree line. Along the 105 degree line, AB, how much AB is there? 200 mm. 200 mm is equal to what? 20 mm. Reduce scale or 2 centimeter. Along 105 degree line, measure 2 centimeter. Through a compass, A is the center, radius is 2 centimeter. Then draw an arc, right? Then you'll get a point B, right? So once you get point B, then join this O and B and extend that line. Join O and B and extend that line. What is OC? How much OC is given? 800 mm. Convert into 800 mm is equal to 10:1, 80 mm or 8 centimeter. Along this line OB, extend this OB line through a compass. Radius is 8 centimeter. Again draw a line which is test the extension of the OB line, that you get point C, right? After that, so from here you can see the vertical height is how much? 400 mm, right? Means 40 mm reduced scale. From the 40 mm reduced scale, draw an horizontal line. Once you draw horizontal line, now we'll get CD. CD is how much? 300 mm is given. Convert into reduced scale, that become 30 mm or 3 centimeter. Take the compass, 3 centimeter radius. C is the center and draw an arc that touches the horizontal line here, which is how much here? 40 mm, 400 mm. Reduced scale is 40 mm from the hinge here, vertical distance. Now that point will get point D. Now once you get point D, in the freehand sketch, you draw this a slider and the cylinder or a horizontal surface, right? And then here also at the point B also, write in freehand sketch, write the one more slider here. Okay, this is how you draw the space diagram by taking suitable scale. First step, identify the type of mechanism. Second step, draw a space diagram by taking suitable scale. What is the third step? Draw the free body diagram for each part of the mechanism. See the link number 2. So the AD is AO is a fixed link, right? We will not go for will not draw the free body diagram for AD because it's a fixed link. Then consider link number 2 here. See the link number 2. I think it is visible. This is the link number 2. Draw the free body diagram for link 2. The link 2 is subject to how many four? Link 2 is connected to how many links? Link 1 and link 4, right? Link 2 is connected to link 1 and link 4, right? What is the force exerted at the hinge A? F12. We don't know the magnitude and direction. At hinge B here, F42. These two forces are parallel each other, acting in opposite direction. We don't know the magnitude and direction. And also at the same time, the link 2 subject to what? Torque T2. Now it is a member is subject to two force and a yes, sorry for there is a network problem here. That's why it is disconnected. Again, it is reconnected here. Yeah. Now the slide is visible. Yes, someone has to give the response.
Yes, sir.
Okay.
Yes, sir.
Okay. Thank you. Yeah. Now we draw the free body diagram for link 2, right? Now the link 2 connected to how many links here? Link 1 and link 4. Then at hinge A, F12 is acting. At hinge B, F42 is acting. And at the same time, the link 2 is subject to what? Here, a torque T2, right? Now the member is subject to two force and a torque. But we don't know the magnitude and direction of those two force and also we don't know the magnitude and direction of those forces and also yeah, we don't know the magnitude and direction of those two forces and a torque, right? Yes. Now after that, 1 minute. Yes. So I think the slide is visible.
Sir.
Yes. Okay. Thank you, ma'am. Now, once you draw the free body diagram for link 2, next we will go for link. Next, what is the next one is free body diagram for link 3. Okay. So this is here. You can see the free body diagram for link 3. The link 3 is connected to how many links? Link 3 is connected to one is a fixed link number 1, and at the same time it is connected to link 4. At the same time it is connected to link 5 also. Now link 3 is connected to
Sir,
yes.
ಅದ್ ಲಿಂಕ್ ಟು ಅರ್ಥ ಆಗ್ಲಿಲ್ಲ ಸರ್, ಅದ್ ಹೆಂಗ್ ಬರ್ದಿದ್ದೀರಾ ಅಂತ.
Okay, 1 minute more. Okay, so see here link 2 is a crank, right? This is a link 2. Just draw a line which is parallel to link 2, AB line. Draw a line which is parallel to AB. Same length you should consider. Here in the space diagram, how much length is there? Same length you consider. The link 2 is connected to what? Link 1 and link 4, right? So link 1 is connected to, so link 2 is connected to link 1 and link 4. At hinge A, see what is the force acting at the hinge A is the force transmitted from link 1 on link 2, that is F12. Then at the hinge B, the force transmitted from link 4 on link 2, it is F42. Is it right? At the same time,
sir.
the link 2 is subject to what? Torque T2. The torque T2 here, right? Is there any doubt, ma?
No, sir.
Okay. Next, after that, link to free body diagram, link to over. Next, we go for free body diagram for link 3. 1 minute. Please move this window away from shared application. Okay. Now we draw the free body diagram for link 3. Now link 3 is connected to how many links? Link 3 is connected to link 1, right? Link 3 is connected to link 1. At the same time, link 3 is connected to link 4, and link 3 is connected to link 5 also, right? Link 5 also it is connected here. Now the link 3 is connected to how many links? It is a what type of link it is? It is also called as ternary link it is, right? Now it is subject to how many forces? Link 3 is subject to how many forces? You can see here at hinge O, the force transmitted from link 1 on link 3 it is F13. The force transmitted from link number 4 on link 3 it is F43. At hinge B, the force is transmitted from link 5 on link 3 it is F53. Now the link 3 is separated to how many forces? 3 forces. If your body make it to equilibrium means subject to 3 forces means all the 3 forces should be meet at a point. That point is called as a point of concurrency. Later will come that one. Okay, we'll come later that one. Next, after the free body diagram for link 3, after the free body diagram for link 3, next, what is the next component here? Link number 4, right? Now you go for link number 4, draw the free body diagram for link 4. Link 4 is what? It is a slider, right? And the slider is connected to how many link? One it is connected to link 2, another one it is connected to link 3. The slider is connected to only 2 links. Again, how many forces are acting here on the slider? From force exerted by link 2 on link 4, it is F24. You can see here, F24. Sorry, yeah, F24 here. And the slider is connected to another one more link here, 3, right? The force exerted by link 3 on link 4, it is F43. One is F23, another one is F34, right? But what is the direction here? Direction will consider perpendicular to the motion of the slider, perpendicular or normal to the displacement of the slider, right? Okay. If you neglect the friction, if you consider friction, later we'll come to that. When slider moves upward or downward, based on that, the pi value will take, the angle of friction will take at the left side or right side. Later we'll come to that one. Next, then you go for draw the free body diagram for link 5. Link 5 is connected to how many links? Is the link 5 is connected to link 4 and link 6, right? What are the force exerted by link 3 and 5? Sorry, link 5 is connected to only 2 links. One is link 3 and link 6. The force exerted by link 3 on 5 it is F35. The force exerted by link 6 on link 5 it is F65. Now link 5 is subject to only 2 forces. Next, last one is the free body diagram for slider. There is one more slider, that is link number 6. If you go for link number 6, how many forces are subjected link number 6 here? One is an external force is subjected, that is how much here? 300 Newton. This F is equal to how much? 300 Newton, right? We know the magnitude and direction of that force. The link 6 is connected to how many links? 2 links. One is link number 5, another one is link number 1. The force exerted by link 5 on link 6, it is F56. The force exerted by link 1 on link 6, it is F16. Right? Again, here the mu value is given. That is a very important. When mu value is given, we have to consider friction at the joints or the sliding pair here. Only the mu value is given for only sliding pair. Now here slider F force is acting here, acting away from the slider in this direction. When force is acting here, the slider also move in this direction only, right? At the same time, at the joint from link number 1 and link 6, a surface that will resist the motion of the slider in opposite to that applied force. That is the F value. The F value will get opposite to the applied force in this direction, right? Okay. So that's the frictional force will come to picture here. Whenever the mu value is given, frictional force will come to the picture. Right? Next, after that, now with respect to that, draw a line perpendicular to the displacement of the slider. Now, which side you will go for measure the angle? The frictional force is in which direction here? Frictional force is in this direction, right? Now, from this, the vertical line and the intersection of this vertical line and force, line of action of force, external applied force, that point we'll consider here. From that point, we draw a line towards F direction, this direction. At angle here, how much here pi value? Pi value is 8.5 degree, 53 actually. No, we will not take 8.53, round up into 8.5, or it may be round up into 9 degree. Draw a 9 degree line, okay, towards the F direction, small f, frictional force direction. Now that shows the line of action of F16. Okay, and one more here, the link 6 is also connected to link 5. Again, link 5 is subject to only two forces. Again, if I want to make it equilibrium, those two forces should be equal and opposite, right? Those two forces should be equal and opposite. They're acting in the same line of action. Now we know that F65, that is equal to F56, right? Now we know the line of action of F56. From the point O, draw a line that shows the line of action of F56, right? Then the external force, we know the both magnitude and direction, but whatever that F16 and F56, the magnitudes are unknown, direction also unknown. Then how do you determine those magnitude and direction of the unknown forces? Again, we'll go for draw here force polygon. I think you know how to draw the force polygon. Again, I will not go for in detail explain for this force polygon, because already we know how to draw this. We know this F. Again, there's a step number 1, identify the type of mechanism. Here it is a quick return motion mechanism. Step 2, draw a space diagram with a suitable scale. The space diagram is also there. Then third step, draw the free body diagram for each part of the mechanism. Next, fourth one, now consider a link which is subjected to a known force. Now which link you have to consider here? Consider the link number 6. It is subjected to known force F. Then determine the unknown forces, the magnitude and direction of unknown forces F56 and F16. How do you determine here? There is step number 4. We're drawing a force polygon, right? How to draw force polygon? Take the scale. What is the scale here? What is the F value? Is here 300 Newton, right? Take 100 Newton is equal to 1 centimeter, right? 100 Newton is equal to 1 centimeter. Then take F is acting towards right side, right? Draw a horizontal line. The starting point of the vector is O. Along that horizontal line, how much you want to measure here? 3 centimeter you should measure, right? 3 centimeter measure, then you'll get point A. Now the length of the OA line shows magnitude of F, 300 Newton. Then arrow mark here, direction is, arrow mark shows the direction of force is acting. Then from point A, now you'll go for in what direction here? Counter clockwise direction force you consider. After F, what is the next force here? F56, right? Or here I think here I'll consider clockwise direction. Sorry, you consider counterclockwise, no problem. This F56 come below here only. Okay, here I'm considering clockwise direction. Sorry, clockwise directions will consider here. No problem, counterclockwise or clockwise direction you take. Okay, that will not get matter here. We'll get below this FY6. OB line comes below OA only. Okay. Now after F, what is the next force here? F. Right. Now draw a line from point. Sorry. Yeah. Draw a line from point A. On both sides, you draw a line from point A parallel to what? Parallel to line of action of F16. The line of action of F16 is 8.5 degree away from the normal to the displacement of the slider. That's a keep in mind here whenever the friction in the mechanism mu value is given. Okay, this is the line of action of F16. We don't know the magnitude and direction. Again, if you say when three forces are acting on your body, the line of action of all these three forces should be meet at a point. There's a point of concurrency, and there is no resultant force, right? Now from the point O again, now it is after F. What is the next force here? Fy6. From point O, I draw a line which is parallel to line of action of Fy6. Then draw here the intersection of line of action of F16 and Fy6. That intersection point will coordinate a point B. Now measure AB, that is a F16. The magnitude F16 is equal to AB. You will get 0.65 centimeter. As you know that 1 centimeter is equal to 100 Newton. You will get how much? 65 Newton. Then measure OB. That is the length of the line OB shows F6. That is BO or OB. You get 3.15 centimeter. As you know that 1 centimeter is equal to 100 Newton. We will get how much here? 350 Newton. F56 is nothing but how much? 315 Newton. Then once you get the magnitude, then I want to get direction. Now when you start from O to A, in what direction is given here? F is acting towards right. Once point A you will get, again I want to reach point O. In what direction I want to go here? From A to B, go upward. From B to O, move downward. That arrow mark shows the direction of F16 and F56. Now transmit that to the link number 6. See that link number 6, F16 is acting here, F56 is acting in this direction. Now transmit this F56 is equal to what? F65, but acting in what? Opposite direction. Now F56 acting in this direction, F65 acting in this direction. Again, link 5 is subject to how many forces? 2 forces. Again, those 2 forces are equal in magnitude. F35 is equal to F65, right? F35 is equal to F65, that is equal to same magnitude but act in opposite direction. Now transmit this F35 over the link 3 here. Link 3 is here, right? F35 is equal to F53. We know this magnitude and direction. Again, link 3 is subject to how many forces? 3 forces, right? Again, we know the line of action, we know the direction also. Extend this, the force line here, right? Again, at the same time, link 3 is subjected to 2 forces, F43 and F13. But their line of actions, sorry, the magnitude and directions are unknown. But F43, the line of action of F43, whether we know it or don't know. How do you know that? Again, you go for draw the free body diagram for link 4. Now, how do you draw the free body diagram for link 4? Link 4 is a slider. Now, when you, okay, 1 minute. Yeah, the slider moves, link 6 moves in this direction means link 5 moves in this direction. At the same time, slider moves also upward. That is important. The slider moves upward. Now, when slider moves upward, see the slider moves upward. Again, slider you consider here frictional force. You consider the frictional force is acting here what? Opposite to the motion of the slider. Again, draw a line which is normal to the displacement of the slider. From that normal, draw an angle towards the small f. Frictional force 8.5 degree. Now that gives a line of action of what? F24 and F34. Once you know the line of action of F34, that is equal to line of action of F43. Right? Now line of action of F34 and F43, once you know that, now F53 already we know that both magnitude and direction we know that, extend that line and extend this line of action of F43, that both those two meet at a point. That point is called as a O. O1 you called as. Already O we used, O1 you take. From the O1, so O already we used, O1 you take, then join O to O1. That gives a line of action of F13, right? Now once you get the point of interest, the point of concurrency for link number 3, again this F53 and F, the magnitude and direction we know that, but the magnitude and direction of F43, F13 is unknown. Then how do you determine? Again we will go for draw a force polygon. Again I will not go for explain this force polygon. You should draw it and send to my WhatsApp number. Okay. From so once you draw the force polygon for the link number 3, Fi3 already we know that, this magnitude and direction already we know that. Then draw a PQ line which is parallel to Fi3. The length of the line shows magnitude and the arrow mark shows the direction. From point Q, draw a line next after this Fi toward the next force. Again here also I'll consider a clockwise direction only. From point A, draw a line which is, sorry, clockwise or counterclockwise? Sorry, counterclockwise here I consider. So make it correction. Counterclockwise force. Once you know the Fi3, then from point Q, draw a line which is parallel to line of action of F13. We don't know the magnitude and direction. From point B again, you draw a line which is parallel to F43. Draw a line which is parallel to F43. Those two lines meet at an intersection point, that is R. Then measure this magnitude and direction. Okay, then you get the magnitude and direction of F43 and F13. Now transmit this magnitude and direction of F43 and F13 to the slider. That is F43 is equal to F34. Right? That is again the slider subject to how many forces? Only two forces. Those two forces are equal and opposite. Magnitude should be same, equal and opposite, acting along the same line of action. Again we know the F24 is equal to F34. F34 is equal to F43. How much you will get when you draw the first polygon? You will get 420 Newton. Then transmit this again. Link 4 is connected to what? Link 2. Now F24 is equal to what? F24 is equal to what? F43. But act in what? Opposite direction. Right? This is equal to this, act in opposite direction. Then F42 is also equal to F12. Right? Again those two forces act in equal in magnitude, act in parallel to each other, opposite in nature. That produces what type of couple here? That produces a clockwise couple. Then I want to apply a torque and counterclockwise. Then you determine T2. What is T2? First you determine H. H is the perpendicular distance between those two forces. H is the perpendicular distance between those two forces, F42 and F12. That will get 1.4 centimeter. Multiply the scale, then convert into inch. That should be in meter. H is equal to 0.14 meter. Then apply the torque is equal to force into perpendicular distance. F42 is equal to F24. That is equal to 420 Newton. H is 0.14. You will get 58.8 Newton meter. What direction it is? The torque T2 is acting in what direction here? Counterclockwise direction. Right? Now this completes the analysis of force by considering friction in the mechanism. Here what type of friction we consider? Friction at the sliding flare only consider. Okay. Yes, any doubt regarding this? Try to, okay, I'll upload this video. Try to see one time or two times. I try to solve this problem. Again, which textbook you are going to refer here? For exam point of view, refer Dynamics of Machinery by J.B.K. Das. For exam point of view. For knowledge purpose, if you want to gain more knowledge, then go for use Ratan. Okay, and Ratan, SS Ratan is there. That's also very good textbook. This is for knowledge purpose. Or Dynamics of Machineries by Ambedkar is there. Okay, so many other authors are there. For exam point of view, you refer the J.B.K. Das. Dynamics of Machinery by J.B.K. Das. Okay. Yes, any doubts? Try to see this video one time or two times, able to understand, then try to solve it on A4 sheet. Then only you come to know whether you are understood or not. Okay. So use the set square, pencil, scale, compass, protractor. Try to solve on the A4 sheet. Okay. Drop how to draw parallel line, perpendicular line. Then only you come to know that. In this is what is a graphical method we call as plus or minus 5% error should be there. In scheme they will give maybe 58.8, will not get 58.8, will get 55 or 60. Then only you get the full marks. Okay, plus or minus 5% error should be there in graphical method. Is the manual errors are there. Okay, yes, any doubt? No doubt? Yeah. Now the last topic in this chapter. Now here in the previous problem, we consider the coefficient of friction where at the sliding pair. Suppose if we consider at the turning pair or revolute pair, you call this, right? Then how do you draw the how do you consider friction, and how do you draw the how do you consider friction, and then how do you draw the friction circle? See the turning pair for forward mechanism, you can see that I'll consider only coupler here. Now if you want to consider friction in the turning pair, now you'll draw the friction circle. The friction circle, what is the radius of friction circle is r into mu. What is r? R stands for the radius of the joint. Is a turning pair, what is the radius of the joint? Okay, and the coefficient of friction between the joints. If you take, then you draw the friction circle here on both sides, and then if you move like this, means one is go upward, another moves downward, means this angle is what about this ABC, this angle is increases, this angle is increases. At the same time, whatever this angle is called as alpha, this angle is decreases. If you consider friction at this joint for a turning pair, for it is again it's a complicated one. Okay, for exam point of view or knowledge point of view, don't bother here, because whatever the frictional force you generated here, that is also very small value, and compared to that the other forces, these frictional forces are small. Okay, when compared to other forces which transmit that motion. Okay, which transmit that motion, the external applied force is more. Okay, friction at the joint is more when comes to when you go for take the friction at the